Okay, so this is the relationship between holograms and scale factor. Activity sheet 1. What would the coordinates of the Black Panther's points be if he was projected using these requirements? Translated 8 units to the right. So in order to do this, you're going to find each point of the Black Panther, his head, elbow, knee, hand, and foot. And each one, you're just going to move 8 units to the right. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then you're going to put your new point for his head right here. And you're going to do that for each one of these. Pause the video here so that you can complete this. All right, activity sheet 2. What would the coordinates of the Black Panther's points be if he was projected using these requirements? Dilation, scale factor of 3. So the first thing that you need to know is what dilation means. When you go to the eye doctor and you get your eyes dilated, what happens to your pupil? It gets larger. And so what we're going to be doing is we're going to be making the Black Panther larger. And so sometimes, because of the placement of the Black Panther, it's kind of hard to see the lines and stuff. So if you take a graphite pencil and you color on top of the Black Panther, it kind of shows up as like silvery. So you can see that a little bit easier. So you can do that on top of the Black Panther. So the first thing that we need to know on this part is what the coordinates are. And so you're going to find the coordinates of each of these points. For example, his hand is negative 1, 2, 3, 4, negative 4, comma 0. And so because your coordinates are x, y, negative 4, 0. Because it doesn't move up or down, it stays on the x-axis. Okay, so that would be negative 4, 0. Pause the video here so that you can get the coordinates of all 5 points. Okay, make sure that our points match. I have the head, elbow, knee, hand, and foot. If your coordinates don't match these, then you might want to go back and double check and see where you messed up. So it says dilation scale factor of 3. So that means that we're going to multiply each one of these coordinates by the number 3. 0 times 3 is 0. 4 times 3 is 12. So our new location for the Black Panther's head is going to be 0x 12y. So what you're going to do on this sheet, you're going to plot this new point, okay? So if we know that this was 0, 4, then we can start counting up to 12 from here. 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to put my new point right here, okay? Pause the video here so that you can go ahead and do these calculations. All right, if your new calculations do not match these, you will want to double check your work and see where you went wrong. Okay, so these are all of our new calculations, and we're going to plot these on activity sheet 2. So whenever you get finished, your new points should be roughly in these areas. Well, not roughly, precisely, actually. Okay, so that's activity sheet 2. Activity sheet 3. You can pause the video to read this information. Follow these directions to create your hologram projector mathematically. On your graph paper, okay, you're going to need a piece of graph paper. Find the on your graph paper, create a trapezoid with the following vertices. So you're going to go ahead and mark the point R, point A, and point P. So pause the video here so that way you can graph this trapezoid. Okay, once you have the trapezoid graphed, you are going to find the length of each of these points. I mean, the length of each part of the trapezoid. So if you count, starting from here, 1, 2, 3, 4, 5, 6, 7, 8, okay, that's the length of the base. The length of the top is 2, and the height is 5, okay? So step 2, that's what we just did. Step 3, using the lengths that you found, make a new trapezoid that is scaled using a dilation of 3/2. We're not going to use 3/2. We're going to use 5/2 because 3/2 just isn't quite big enough. So we're going to use 5/2 instead. And we're going to put this trapezoid, it says put it in quadrant 4, but it really doesn't matter where you put it. You just want it to be the correct size. So what we're going to do is we're going to multiply each of these lengths by 5/2. So 2 times 5 is 10. 10 divided by 2 is 5 times 5 is 25. 25 divided by 2 is 8 times 5 is 40. 40 divided by 2 is, pause the video here so you can double check your calculations. So if these are not the new numbers that you got, you want to go back and double check and see where you kind of got it wrong. Okay, so our new top length is 5, our new height is 12.5, and our new base is 20 units long. So you're just going to go somewhere, okay? It doesn't matter where. You could do it on the back if you wanted to. You just need to have a space that's big enough for this base. Okay, so you're going to start with a point, and you're going to make sure that it's 20 long. All right, we're gonna go from one point and count up 12.5, and we're gonna put that half marker, and then 20 minus 5, which is the top, is 15. 15 divided by 2 is 7.5. So we're gonna move to the right 7.5 from our height location, and that's gonna put us right in the middle of the square. So you're going to put a point in the middle of the square, count over 5 because that's our new top length, and then this is going to be your new trapezoid. So once you have this, you are going to trace it on the transparency 4 times. Okay? Once you have 4 trapezoids cut out of the transparency, you're going to line them up like this and tape them. Okay, the most important part of this is to make sure that these edges line up. Okay, once you have all 4 taped together like this, you're going to pick it up. I put tape on one piece like that, and then I bring it together and I let them meet, so that way I know that it'll stand. And you're going to have your projector just like that. So how do you test your projector? What you're going to do is you're going to find a video on YouTube, search for Hologram, and it's going to have 4 of the same thing on it, okay? You're going to place your projector on top of that video in the middle like this, okay? And then you're going to look at it from the side, and it's going to look like the image is floating in the middle, but you have to look at it from the side. And that's how you make the hologram projector.